Okay, let's look at 1.3, Unit 1.3. We are still in Unit 1, and we're still in the main method, but what we are doing here is moving on and adding a little bit more to what we've already done. So here, we are talking about variable assignments and calculations. So we did this one before. We have declared the variable value. It was an integer. It's 4 bytes. And now we are assigning it the value 20. Let's talk about assignment. This equal means assign. What it means is take what's on the right and put that value into this variable in memory. Same is true here. We have the cost variable, which is a double. That's why we have a decimal. And what we're doing here is we're assigning 19.99, $19.99 to cost. We also assign true to is empty. These three are primitives, if you remember. Now we have the objects on the bottom, and there are two ways to do the assignment. Now that's for strings and for integers and for doubles. Objects. You could use the string literal to assign the name Peter Parrot. You could also use a string constructor, which is the keyword new, the name of the class string, open parentheses, and then we put in the literal in here. Same is true for integer. Even though you could do this by assigning the int to the object, this is not actually possible, okay? Because we can't just decide to assign any type to any type. Like you can't assign, let's use two types that are not here. For example, I can't assign a video to an image. That doesn't make any sense. So what we're doing here is we're assigning an int to an integer object. Well, that doesn't actually happen. What they do is something called auto boxing. It would take the integer and turn it into this. That's why I have this little note right here. So on the bottom here, this is what actually happens. Even though we can write it in the shorthand way, this is what happens. Okay. So auto boxing is taking the int, the primitive, wrapping it into the integer, and then assigning it. Same is true down here. Okay, we're doing the same thing with the double, wrapping it and assigning it. Now we have an example here, 5, and it says, what would happen if you were to try to print this thing? And we would get 1, 2, 3. How do I know? Here's a string. And I already said concatenation, the plus, would take anything that's not a string and turn it into a string and just put them together. So even though this is an object and this is an int, we have a string, and if we print this, we'll get 1, 2, 3. Example 6. Example 6 here says, what about if we do the wrong type assignment? Okay, we already see up here that these were wrong types, but the system took care of it for us because they were close enough. Let's look at this one. We'll get an error here. And the error comes because we cannot assign a double to an int. Why? A double is 8 bytes. An int is 4 bytes. Just think about it as like fitting it into memory. You can't fit 8 bytes into 4. It's just too much. Okay? So because of that, this is called a narrowing. Okay? We're going from a wider guy, a bigger thing, 8, down to 4. That's narrowing. This type of assignment is possible, but we're going to need to do a cast. And we're going to see that a little bit later. Okay? So as it stands right now, it's not possible the way it is. Okay? We have to cast. So I'm going to comment this out. But then you look at this one and you say, wait a minute. You just said you can't just assign a double to an int. But how could you now assign an int to a double? Okay. This is called a widening conversion. Okay? So when you widen, it means we're going from a smaller 4 bytes to a bigger 8 bytes. We are getting bigger. That's possible. And what do I mean by that's possible? The system will do that cast for us. So the way it works is the programmer has to do the narrowing cast. The system does the widening cast. Okay. Now, it's not true that every type can turn into every type. These are only going to be true because these are numbers. Okay. So when it's possible to cast the narrowing type, the programmer has to do that, and the widening type, the system does it. Okay. Let's go down a little bit and let's start looking at some examples. So here we have some calculations. All these are from the Introduction to Computer Science. Okay, if you've never done this before, this might be a little strange, but this is something that we covered. So these are all things that we know. We know this little percent sign means mod. This is divide, this is multiply, subtract, and add. So we are trying to do the order of operation and figure out what the console would look like. So let's take example 7. We have an int, okay, 4 bytes. It's assigned a 3. Then we have a double that's not assigned yet. The double gets assigned down here, but the double gets assigned with integer calculations though. It's kind of weird. So we have the widening style conversion here. That's okay because the system will do it for us. So let's calculate. 3 plus 1 is 4, parentheses first, times, multiplication is next, 3, which is 12, divide by 2, which is 6. Yes, that's 6. But when you assign it, it becomes 6.0. How so? It's a double. Double has decimals in it, even if it's 0.0. It's going to print 6.0 and it's going to go to a new line. You see how 1.1 is coming in here? Because now we have to look at the prints, right? New line, no new line, new line. Let's calculate again. N divided by 2. So n is still 3, did not change. 3 divided by 2, you would think 1.5. Wrong. It's an integer. You can't get a 0.5. That would be a double. So the answer is 1. If you wonder what happened to the 1.5. 1.5, and the word is truncates to 1. What does truncate mean? Delete the 0.5. Just get rid of it because it's not the right type. See, this thing here, the idea of type, you got to assign to the right type. So now that 1.5 becomes a 1. 1 gets multiplied by 3 plus 1, which is 4, and we get 4.0. How come? This is a double. 4.0 is what we're going to get, not 4. So now we print. But that 4 is going to be printed on the new line. Why? Because this thing printed the 6.0, dropped to a new line, then we print the 4.0, but do not drop to a new line. The very next print is going to print right after the 4.0. Okay, so what's this one? Well, 1 divided by 2 is 0. How come? It's actually 0.5, and that's going to truncate to 0. Okay, why? Because it deletes the 0.5. So now we have this 6.0 drop to a new line, 4.0, and then put 0.0 right next to that. Let's look at the example 8. This is doing some mod here. So we have an int r and it's equal to 0 to start. Okay, it's assigned to 0. And then we have a 17 mod 3, which is 2. Okay, 3 goes into 17 5 times, remainder 2. And a mod gives the remainder. It prints the 2. But guess what? It doesn't go to a new line. And then it does 8 mod 2, which is 4. Okay, this is 4. So because it's 4, that's wrong. It's 0. 8 mod 2 is 0. Because 8 divided by 2 is 4. Remainder is 0. This comes to 0. And so 2 prints. The 0 prints. So it kind of looked like 20, but then it drops to a new line. And here's another calculation, which is a divide by 0. Look, this is a divide by 0 error, which is called an exception. Because if I get 8 mod 2 and the remainder is 0, and I try to do 4 mod 0, I'll get a divide by 0 error. So we're going to run this, and what we're going to do now is check to see what happens when we run this. Okay, so these are all the stuff that we had from before. Let's slide this over slightly. And we're going to start off with here, right? This is the 1, 2, 3. Remember the 1 in as a string, and then the 2 as an integer object, and the 3 as an int. 6.0 dropped to a new line, 4.0, and right after we got 0.0. 20, which is actually the 2 and the 0 we talk about, and then the divide by 0 exception. So now, this type of assignment and calculations and all of that, this is a big part of computer programming because we have to work with data and manipulate them and do things with them. And this brings us to the end of 1.3. In 1.4, we'll pick it up from right here and add a little bit more to this.